So today's topic is organizing, visualizing, and describing data. My first question to you is, Abhijit, what is data?
See,
Can I say data is some kind of raw material which which when processed gives you a valuable information based upon
yes,
which you can take decisions?
yes,
So for example, if in school days you used to get jumbled sentences, that means the sentences were not in order. So that was a raw material kind of thing, a data given to you, which when you process them or when you rearrange those jumbled sentences in proper order, so that like after rearranging, a proper meaning could have been understood from that, and then you could draw some conclusions out of that. Am I right?
yes.
Data is a raw material which, when processed, gives you valuable information based upon which you can take crucial decisions. Okay, so now that is data. But here the question is identify and compare data types. So now
Okay.
since we have understood what is data, we will understand what are the types of data. So the term data encompasses information in any form. That means when processed, not directly, you may get processed data even. That's not a matter of concern. So for our use as analysts, we must classify data types from three different perspectives, they say. One is numerical versus categorical. So when I say numerical, it definitely deals with numbers. Categorical, it definitely deals with categories. Am I right?
Okay.
Then, sorry,
Yeah, please continue.
any doubts?
No
You
answer,
said
sir.
something to me. No.
No.
Okay. Then comes time series versus cross sectional. I'll come to this. Then comes structured versus unstructured. Okay. First, let us understand about numerical versus categorical. See, numerical data or quantitative data. Since it is numerical, it is quantitative because you can count here. Am I right? So
Okay.
you can definitely like the values that can be counted or measured in this. Numerical data may be discrete or continuous. So what is discrete? Something which is countable. Example, months, days, hours in a year. Can we count this? Yeah, it's a discrete data. And it of course is a numerical data. Something which is in terms of numbers is always a numerical data. Continuous data can take any fractional value. For example, you throw a die, there are six
Sir,
outcomes,
sir,
and
sir.
the
Hello.
probability of, hello,
Yeah, your
yes,
voice was breaking for 2 minutes.
now can you hear my voice?
Yeah, now it's okay.
Yeah, see, if I take into picture distributions, which we are going to study in the coming chapter, what is a distribution? See, suppose this is a coin. Okay,
One second,
you
it was
talk.
breaking. Sir, it is breaking. So how did you get to distribution suddenly? We were doing continuous and discrete data, no?
Abhijit, do you think distribution cannot be taken as an example to explain you about discrete data?
No. You see, since your voice was breaking, I did not fully follow, so that is why I asked.
Okay. No, I thought that you're like questioning like something.
No.
I didn't get that.
Uh,
Okay.
you see, uh, okay.
No. Don't take it either way, dear. I'm just asking you. That's it.
No, I didn't
So,
understand because we were
oh, no worries, no worries.
there was a lot
Always,
of noise.
always. I don't understand. What's the problem today? No, I took a class very clear, comfortably before. I'm
Mhm.
extremely sorry if things are like that. Oh my God, what is happening these days? So I'm always available. Okay, always ready for your doubts, dear. Don't worry. So see, I'm trying to explain you something with a distributions example. So
Uh-huh.
see, this is a coin. If I toss this coin, see, if I take this, if I pick this coin, I am picking it randomly. Okay, point number one. I am tossing this coin. It's a random experiment. Okay, that random experiment has two outcomes. That is, always head or tail. So I will give two numbers to that to those outcomes. Let's say 0 and 1. Understood?
Okay.
these two random, these two numbers, what I gave to this two outcomes, which can be head or tail. Okay. This two would be, this two I would denote with X. So here X can be a random variable.
Which can occupy two, or discrete random variable which can occupy 2 or 1.
Yeah, see, X can be a random variable which can take any of these numbers when this coin falls, and the probability for this is 50% and 50%. So if I take this data in this way, in a tabular representation, whereby I put X as random variable 0, 1, and I take the probability of that as 1 by 2, 1 by 2. Can I say this is a distribution?
Yes, you can.
A
Yes.
probability distribution, correct?
So
now, why I took this probability distribution? Because you can really count the outcomes here. Am I right?
Yes.
So there are two outcomes in this case. So that is discrete. But if I take something in this way, so I'm taking the help of a normal distribution. See, distribution is nothing but it's nothing but representing the outcomes with their probabilities for some random experiment is probability distribution. Because if you perform some random experiment, that random experiment will have some outcomes. Outcomes will have some probabilities. Outcomes with their corresponding probabilities shown in any ways, either in this way is a distribution. Okay. So now you got some idea about the next chapter as well in advance. See. So if the rainfall I want to check, okay, and the rainfall is in the range of 2.2 centimeters. I don't know the rainfall ranges. Okay, just I'm taking a random thing to 2.5 centimeters. So it can take any number between this, Abhijit. Am I right? 2.1, 2.114, 2.22896. So anything, this is continuous, which you cannot count. Why? Because see, something simple I will say, if you take normal distribution in this way, this can be a very good example of discrete because you can count. But if I just join them, it becomes continuous because no gap, correct? Categorical or qualitative data. See, the thing is very simple here. Here there is no usage of numeric values. We are just taking into consideration the categories or the quality. Okay, consist of labels that can be used to classify a set of data into groups. That means we will call something by its name, or we will classify some data based upon some names. Very simply understood. We take fixed income mutual funds. Okay. Fixed income mutual funds can be of any category. Am I right? We can put any label to them, like corporate bond funds, municipal bond funds, international bond funds. Can we do that?
Yes.
So even we assign numbers to the categories, like number 1 to corporate bond fund, number 2 to municipal bond fund. So the numbers are arbitrary. Like, see, I can't give any ratings or rankings to them, correct? I'm just randomly taking numbers and putting them in order. That's it. But the categories are very clearly understood that these are the fixed income, mutual funds can have these kind of categories. It can be of corporate, it can be from corporate sector, it can be from the from government, from local governments, etc. Okay. Now, ordinal data, very simply understood again, that can be something understood, that can be understood in such a way like you can rank something in logical order. So can I say that is ordinal data? You are putting things in order. Okay. For example, ranking of 1,000 small cap growth stocks by performance may be done by assigning the number 1 to 100. That means you're putting things in order based upon their rankings. It's a ordinal data. Now, any idea about time series and cross-sectional data, Abhijit? If I can get some info from you.
If you sample data at regular intervals of time, it may be considered as time series.
Can you give a good example here? I would be very happy.
You see, revenue, total revenue as on 31st March for the past 10 years.
Yeah, that is a random, that's a time series data. Very good. We'll take a good example and understand that. And what is cross-sectional data?
Honestly, I have no clue.
So nothing but you are not taking only, you are not considering only one thing here. You are considering more than one things. I'll explain. Time series is a set of observations taken periodically. Set of observations taken periodically. Most often at equal intervals, maybe 6 months, every 6 months, or every day. Let's say anything. Over time, daily closing prices of a stock. So did you get time series is focusing only on one element? Understood?
Yes.
Focusing only on one element. That means you are collecting data of only some single thing or only of some single stock in this example in regular intervals. Okay.
Yes.
Okay.
Huh.
And that is nothing but an very good example of time series data. But cross-sectional data refers to set of comparable observations, all taken at one specific point in time. Today's closing prices of 30 stocks in Dow Jones Industrial Average. That means we are not taking one thing, we are taking more than one thing, and we are collecting data of that. That is cross-sectional data. Okay, so no problem. If you want to put more like emphasis on this, I would give you a very good example here to understand, so that you should not forget in your lifetime. And we will discuss about three types of, we will contrast three data here: time series, cross sectional, and panel data. Okay. Statistics, when studied from very good basics, is always, it makes things very simple and easy. Studied just like that, definitely it's a disaster. So time series data. It is a collection of observations So I'm putting observations and bracket behavior, correct? We are studying behavior of something. For a single, they may give you MCQs based upon all this info. If you have good knowledge, you may be able to do the MCQs. So it is a collection of observations, behavior for a single subject. Let's say that single subject can be any entity at different time intervals. Okay, generally equally spaced. That makes sense.
Yes, that makes sense.
Collection of observation. That means you're checking the behavior for something at different intervals. So I can give you what behavior you're checking. Max temperature, humidity. See, this can be used in any area. In the world of finance, I can say EPS, stock price. And but now if I have to put things based upon this definition, how will I put? So I'll take it in this way: max temperature, comma humidity. These two are different things. And wind. All are what? Three behaviors, correct?
Huh.
Because we check the behavior of these things. In New York City. New York City is what? Single entity, correct?
Yes.
Collected on first day of every year.
Oh, okay.
Multiple intervals of time. This can be a very good example to understand this. We'll put the things on a table here. Some data I have. City, New York City, date. I'll take like 2022 maybe. So I'm taking the yearly data here. Let's say it start from 18, 19. Max temperature, humidity, wind. So these three behaviors you are studying, okay, and in some single entity and at multiple intervals of time. That means equal intervals. I would say all are equally spaced. Okay. So now the intervals are 1 year here. Am I right? Every year you are studying New York cities, these three things. Can I say this is a time series data? Or if you study only max temperature, it can also be a time series data. Understood?
Yes.
Three miles per hour, 21 miles per hour, 16 miles per hour, random things, 4 miles per hour. So we'll now do cross-sectional data. Okay, have a look to this. We'll move forward.
Yeah, I understood.
Now cross-sectional data. What are you calculating, Abhijit?
I'm not calculating anything.
I'm just hearing some sound.
No, probably the book.
Okay. Now let's see the cross-sectional data. So cross-sectional data, it is a collection of observations behavior for multiple subjects. That is entities. Okay. So what I mean here is in time series, you studied the behavior of all these things only for one city. In cross-sectional data, you're going to study the same behavior for all those things above mentioned for different cities. Understood?
Yes, understood. So the same rainfall, wind, humidity, temperature for a couple of cities.
For New York City, for San Francisco, for Boston, for Chicago.
Okay.
Yeah. So example, we can take max temperature, humidity, and wind, all three behaviors in New York City,
Excuse me.
San Francisco, Boston, Chicago. Multiple entities. But now you should understand one more thing. Here we are only taking single point in time. We are not taking at different intervals. Understood?
Okay.
So we will take only on 1/1/2015 single instance. This is the most important aspect of this. See, if you see the definition and all, you won't understand very clearly, but example would be better. City, New York City, San Francisco, Boston, Chicago. Date 1/1/2015. Max temperature 55, 70, 34, 29. Humidity, again it can be 45%, 35%, 39%, 15%. Okay. Wind can be, hello.
Oh, yes, sir. Yes, please go ahead.
Yeah, 4 miles per hour, 21 miles per hour, 16 miles per hour, and 54 miles per hour. So this is what the difference is between them, correct? There we took all the things, temperature, humidity, wind. We studied only for one city and we studied for different years. Here we are studying for different cities, one only for 1 year and the 3 different things, correct?
Yes.
Now the next one is panel data.
What did a panel data?
Yeah.
Okay.
You have the panel data as well in your this thing.
Oh, is it? Okay. Yeah, I don't doubt you. Please go ahead.
Yeah, no problem. I'll show you. See, these all seem to be very simple and school level, but you know, they give MCQs in this. And really that time it seems very simple, but we lose out. We cannot remember everything from the school life, now. All is not, we can't remember. So we can just recall once panel data. Okay.
Okay.
So now when it comes to panel data, I can say this is a cross-sectional time series data, okay, or combination of both. So I can also put this as longitudinal data. There is an exam called Indian Statistical Institute, okay. So if it's a course like a chartered accountancy course, it's a professional program. Only you study more of only like statistics at the highest level. So then these things very much easy. It becomes very easy for you. It's usually called as cross-sectional. Abhijit, are you following?
Yes, sir.
Time series data. As it is, they gave just a sentence, but they did not give any example for that. It's a combination of above mentioned types. That is collection of observations for multiple subjects that is entities, that is cities, correct?
Yes.
At multiple instances. So what we can differentiate is in time series we took only New York City, different years, correct? In cross sectional we took 4 cities, 1 year. In this we are going to take all those cities, different years. Understood?
Okay.
One city, different years, time series. See, one city, different years, time series. Like different cities, 1 year, cross sectional. Panel is nothing but different cities and different years. Understood?
Okay, let me just take a screenshot.
One city, different years. Okay. Different cities, 1 year. Okay. And then different cities, different years. Understood?
Yes, yes, understood. This is a good point. Yeah.
I'll put this here.
Just 1 second, I'm writing it down.
Okay, right. Take. No problem.
Cross-sectional is, so for cross-sections, different cities.
1 year, in 1 year itself. In single point of time.
Okay, single point time. Okay. Parallel data is different cities, different time, different years, no?
Yeah.
Okay, thank you.
So multiple subjects at multiple example we'll take. Max temperature, humidity, wind, all three behaviors in New York City, San Francisco, Boston, Chicago, multiple entities. Okay, on first day of every year, multiple intervals of time. It makes very sensible thing, correct? You're writing, Abhijit?
Yes, I'm just writing it down.
Yeah, please. What's the time there? Today we started very late. I'd have very less time.
Yes, it's done.
Yeah. So I'll put the example here. City, date, max temperature, humidity, wind. New York City, San Francisco. Okay. Because we are taking multiple years, no?
Yes.
We took for San Francisco. Okay.
Yeah.
Finished?
Yes, sir. What do we? Can you just tell me again what we're doing here?
This is panel data.
For multiple cities at the same point in time, different years.
Different years, yeah.
Okay. Okay.
So they have given the example. You can go to that, Abhijit. Then I'm just explaining you structured and unstructured data. Fine.
Okay.
See, structured data is like this is the structured data. Time series, cross-sectional panel data are structured data. But because those are very analytical, now you can easily understand. Unstructured data doesn't have a proper structure. Okay, there's no defined structure for this. Management's commentary in company financial statement is an example. They can give it in any way. They can put anything first or last. Am I right?
Yes.
Or one way of classifying unstructured is according to how it's generated. Data may be generated by individuals such as posts on social media, generated by business processes such as deposits, withdrawals, and transfers of cash. There's no structure for this. It's unstructured. Correct. Something generated by the sensors such as satellites or traffic cameras. Do you think like anything in this like paragraph kind of data whereby everything is not in a proper order, not structured? Understood?
Okay.
So these are the examples of unstructured data, Abhijit. Any other example like you can give?